Hello, hello. Perfect. Okay, so I think that we can start, ladies and gentlemen. Good morning, and let me welcome you on CORE 2025 conference here in Conference Center of UJVZ. It's nice to see all your faces here, and we have also some people connected online. My name is Otakar Freeboard, and together with some colleagues, Jiří Duspiva, Pavel Mareš, Jaroslav Brom, and Marek Mikloš, we will guide you through the entire conference day. This is the second edition of CORE conference, which is based on previous 5 years of SUSAN conference organized by Research Center Rzesz. The SUSAN conference was based on the results of SUSAN projects. The SUSAN means sustainable energy, and this project was solved between 2011 and 2015. This project led to construction of significant infrastructure here in CER, and part of the infrastructure was later connected with research reactors, which are operated here at CER, to the large infrastructure CICER. The infrastructure CICER will be later introduced by Marek Mikloš during the afternoon session, and it will be followed by several presentations linked to the results obtained through the infrastructure operation in frame of open access projects. The conference day will be divided to 4 sessions: manipulators, NDT, open access, and later excursions. During the day we will have 2 coffee breaks and a lunch. The lunch will be directly here in the hall. We prepared also small poster sessions, so you can use the time during the coffee breaks to see the posters. For the participants which are registered for the afternoon tours, they will be checked in by colleagues from reception during the second coffee break at the end of the part organized here in Conference Center. The group will be split to 2 groups, and they will have, or you will have possibilities to visit hot cells, which is a part of the infrastructure CICER. It's quite unique, so I think that you will enjoy it. And the second part will be organized at the experimental hall, and you will see some example of manipulator, of some advanced measurement technique, and we will also show you our facility LOCA, which solves for qualification of the components for nuclear power plants. The tour will be guided by our colleagues from communication, Jan Trejbal and Tomáš Sobotka, and let me also thank them for the organization of the conference. Finally, we have a small gift for all speakers for their effort here. And now, allow me to hand over the floor to our first speaker and officially open conference CORE 2025. I hope that you will enjoy it.
Okay, hello everyone. Can you hear me also in the back? Yeah, perfect. Welcome you on CORE 2025. My name is Bohuslav Kolar, and I'm technical expert from chess company. My field is NDT, mainly X-ray. So if you have a question regarding the X-ray, that's on me. We are really glad that we can open the CORE 2025 and a little bit show off to our manipulators and manipulated techniques we are using in chess in nuclear division. I hope you do know, but for the ones who doesn't, We have 2 NPPs, 2 nuclear power plants here in Czech Republic, one in Temelín, the second in Dukovany. All VVE are designed, and the yearly outage is around 31 terawatt. 30.4 was in 2024, and that is almost 40% of the Czech total power needs. So nuclear division is really important part of the Czech company and of the energy of the power spectrum here in Czech Republic. Regarding the NDT, what we are doing about NDT. So right now we have approximately 150 internal certified NDT employees. That means that 90% and hopefully in the future 100% of the NDT inspection we are able to cover by ourselves. That's quite a huge number. Number of the inspection this year is somewhere between 30 to 35,000 for both NPPs, of course. And in the future, two more or 4 blocks are coming. You know, maybe that we have a contract right now with Koreans. So hopefully in the future we will build new one, because as I said, the nuclear energy is a really important part of the energy spectrum here in Czech Republic. And of course, to, let's say, topic which is really connected with the manipulators and everything, we are having around 70 qualification of NDT processes. I will be speaking a little bit about the qualification later. So here you can see the list of our manipulators, and of course we have more. So that's just to show how much manipulators we are using for different purposes. Here in the picture you can see IRIS, manipulator IRIS, which is manipulators for heat exchanger tubes in steam generator. So and the question for today, why the manipulators are so popular, maybe also a bit expensive topic, right? So why, that's a really important question. Why we have to use manipulators for NDT? Well, first, we have places in power plant with high radiation risk. So radiation safety is, of course, really important point here. So you cannot send the human inside of the reactor pressure vessel, right? So you have to have a manipulator to perform the testing in there. So first is radiation risk. The second, of course, is also the safety of the personnel, not connected with the radiation, but you can have also, or you are having different types of problems in the technology, which doesn't have to be really safe for personnel. So you will use a manipulator for it. And third, and of course there is a more reason why I use manipulators, but third is of course quality. The repeatability, the reliability, and lowering the human or personal influence of the operator is really, really important, and it has really high effect for to increase the quality of the testing. So these are 3 really important points why we are using manipulators. So, and as I promised, the topic which is really connected with the manipulators are qualified inspections, right? We are of course qualifying in accordance with the ENIC rules, but I can proudly say that we have our internal system for qualification of the processes. You can see our inspection procedures on the left. So Of course, we are guided by ENIC, but we built and are using our internal system, which is a bit unique in Europe, but we see it as more efficient than to use external qualification body and everything. So this is really important for us. As I said, we have a 42 qualification in UT, 15 in eddy current, 2 in X-ray testing, radiography, of course. And let's just see three qualifications which are quite important for us. Heat exchangers tubes of steam generator, VVER, Temelin, even Dukovon is so 440 and also 1000. As you will see later, we are using the iris manipulator for it. So, and we have a qualification for eddy current testing of the heat exchangers tubes, as you can see here. The second is, which starting to be actually quite important. So dissimilar metal wells for small thickness piping using phased array technique of ultrasound. The small thickness using the ultrasounds are a bit challenging, of course, but we have qualification. We are, of course, using manipulators and everything, and it seems to work pretty well. And the third, just to show you its qualification for main circumflexion pipeline well joints on Temelin NPP. You can see the line between the pressurizer and the main circulation pipeline. So this is the third qualification. Well, we put, to show you some of our manipulators, we put everything into the chapters. So first, we will look at the manipulators we are using for reactor pressure vessel. First, and the most important manipulators is MKS, which we are using for pre-service and in-service, right now in-service inspection, of course, for inner surface of the pressure vessel. So really important things to do. This is a second generation of the manipulator. Manipulator is fixed on the pressure vessel, on the dividing plate of the pressure vessel, and you can perform UT, ET, and of course visual testing of the inner surface of the vessel. So this is really crucial manipulator for us. You can, as you can see, there are. Okay, sorry, it's not working. On the left, the bottom of the picture, you can see people. So you can see the scale, how the manipulators is in size approximately. So this is the real size to the people. So pretty massive. The second, of course, also really important manipulators for Temelin and PP for visual testing of the inner parts of reactor, so active zone and inner and outer surface of the shaft. And so as you can see, just for visual testing, of course, in the really high radiation zone. So when you are testing in a part of the reactor, there is a really high radiation risk. And for Temelin and PP, we are using SK1187, which are manipulators for bottom part of the reactor and other surface of the reactor. Using eddy current testing and visual testing, you will put the manipulators to the bottom of the reactor, and there is a hand which rise, and you can test also outer surface of the reactor. And of course, for let's say smaller parts of the reactor, not just like pressure vessel and everything, we are using manipulators, as you can see, as for example, Comash for bolts. So for UT and eddy current testing of the bolts, we are using this small machine. And the second, Yekosh, so in-service inspection of the nuts and threaded hole. So we can expect the hole on the reactor. So we are using for this we are using eddy current, of course, visual testing. Just visual testing is actually propagated through using the mirror. So using the mirror, you are watching not just on a surface of the threaded hole from the up, but you can see also the surface from the bottom. So you are using just a mirror for it. Well, and the really second quite important part of the VVER design and also quite the pain of VVER design are steam generators, of course. For steam generators, as I said, we are using the Iris manipulator. Iris manipulator, actually, it's quite a machine. We can do lots of things using this. Also, I think the second generation of the manipulators for it. So mainly we are testing the heat exchangers tube. Of course, we can also test the surface of the collector. And we are using ultrasound, eddy current testing. We can change a head for penetrant testing and also visual testing. Everything is propagated with the changing head. So there is a body of the manipulators, and you are changing head of the manipulators based on which NDT method you want to use. Right now, we are thinking about to let's say, prepare a new generation of manipulators for these kind of testing. And again, same, for example, as for reactor, we have to inspect the threaded holes. So for threaded holes, we are using these up manipulators. As you can see, for eddy current testing and visual testing, we can test all the threaded holes in a up part of the collector of the steam generator. COSUP, again, small part of the steam generator, so bolts mainly. We are using, again, ultrasound and eddy current testing. And of course, also for bolts, ROMAX, which is using just magnetic particle testing. Well, and of course, this was just the main manipulators which we are using for, let's say, big equipment. But we have many more manipulators which are actually smaller, or okay, COWOC is not smaller actually, but can be smaller, can be modular, can be semi-mechanized, and we are using it mainly for ultrasound testing. So that's really important for us from the point of view of the repeatability, which starting to be really important, mainly for Dukovany NPP, because as you all know, Dukovany NPP is not really new. So we have to assume the long-term operation of the unit. So for long-term operation and to precisely do long-term operation calculation and everything, you need also have a really repeatability in the case of NDT testing. So that's why we are using lots of manipulators for ultrasound. So that's really important stuff what's going on right now. Okay, thank you again. Thank you for let us open the conference. It's our privilege for us, and I'll be here all day. So if there will be any question, on me. So do we have a time for questions? So yeah. So any question? Great.
I have a question for the manipulator which inspect the thread holes. It's only for like one side of the thread hole, or?
Well, yeah. Can you repeat the question? I don't
repeat it for online guests. I have a question for inspect robot or manipulator which inspect the thread holes.
Okay.
It's only for one size of the holes, or it can inspect the more sizes?
Basically, the design of the manipulators is for equipment, so for steam generator. In case of the steam generator, there is a different manipulators for 1000 and 440. So we have different manipulators for Ducon and for Temelin, so different sizes. But there can be a bit, let's say, time to time, you can see a little bigger hole than the others. Normally, I think is for 48, and you can see also 50 and 52. So you can do also this small deviation with it, but it's not that let's say manageable that you can do, I don't know, 10 millimeters and 100 millimeters. Yeah, there is few millimeters you can do with it, but it's designed for the certain equipment.
Perfect, thanks.
Yeah, right. If there is no more questions, thank you for listening and see you around.
Okay, thank you for presentation. And now let me welcome second speaker, who is Jiří Netušil. Okay, let me briefly introduce Jiří. He graduated in 2005 from the Technical School of Mechanical Engineering in Pilsen. From 2006 to 2020, he worked at Doosan Škoda Power in several technical positions, primarily as a steam turbine designer. In 2020, he joined CVR as an R&D engineer, where he is involved in development and design of diagnostic manipulators. Jiří, the floor is yours.
Okay, thank you for introduction. Hello, everybody. So, as my colleague said, I'm Jiří Netušil, and I'm a mechanical designer here in Center. And my presentation will be about a particular manipulator that we just developed here. Yeah, it is still in development, but let's say it's 95% finished, so it can be presented. Okay, it's for inspection of hydro generator, which we wanted to use air gap for. So, and it will be for inspection in assembled state. So with the rotor inside, only the shields will be removed to access the air gap. And the air gap is basically the clearance between the rotor and stator. It's about, I don't know, 20, 30 millimeters wide. So the manipulator must be quite thin. And it checked the surface of the rotor and stator, the windings and the poles, and to perform visual inspection to find some defects. So we were inspired by some existing solutions which are performed by various companies, and basically all of them are typed with the belts, which are called crawlers, and they perform visual and LCID tests. So they have the cameras, they look onto the stator, rotor, and into the front mostly. And we have found that the minimum thickness is about 20 millimeters, and they are positioned manually, so they can go usually only if the generator is in vertical position or the axis of rotor, so they can go up and down. So what we wanted to do was some improvement. So we set our design criteria, mostly the thickness, which we set to 14 millimeters. And we also wanted to do double axis motion, so it could go up and down and sideways also. We want to use visual test and LSIT. So for LSIT, actually, it's not on the manipulator itself, because the technology is quite expensive, but we made some interface for LSIT, and we also plan to do all the necessary like cables for running the LSIT, like power and the lines and well, everything, just what is needed for it. And we made the manipulator for various design of hydro generators. That means mostly the diameter of the rotor, which may vary, so it can fit to a wide range of the diameters, and also the span of the poles, so it can go over them. It may be better explained on the next slides. So this is the manipulator. One is 3D model, other is the picture of the real thing. And you can see, is that a laser pointer? Doesn't have pointer, okay. So on the right side, there's the one. It's so far it's made of plastic by 3D printing, the main body, but when it's gonna be 100% finished, then it will be made of aluminium. So the materials are mostly aluminium and the stainless steel. And the manipulator consists of the central body with PCB, with the electric circuit. There are front and rear cameras. On the both sides, there is one camera that looks front, and one which looks up and down, and that's done by the mirror. So one camera has two mirrors, and half of the camera looks on the top and half on the bottom. And the same is for rear side. On the side you can see adjustable wings, where they can adjust by the angle, and thus that can go into the different diameters of the rotor. For motion, we use longitudinal and the transverse belts, and underneath the belts there are a permanent magnet, so the manipulator can stick on the ferromagnetic, the metal surface. On the transfer belts there is a jacking system which allows the manipulator to disconnect the transfer belt and connect the longitudinal and again. We will have this manipulator on the afternoon tour, so it's better if we can show you that if you want. The manipulator is connected with a standard cable, so it's remote controlled. And there is that small pocket on the front. It's interface for LSIT probe. Okay, on this video you can see the manipulator moving in longitudinal direction. We use the mock-up, which we made. It's basically the steel structure with those surface that resembles winding of the stator, and it can be interchanged for other parts, so it can simulate the rotor also. It is quite handy. It can be placed vertically or horizontally, and we are testing the movement there. Yeah, here are some videos from previous testing of the first prototype when we tested only the module for from one direction movement and the cameras. It was on a real power plant in Dalešice, and on the left side it's without rotor. Outside there is a different version with rotor inside, and there is PCB integrated in the body because we cannot fit it outside like that funny bag on the left side. So that was testing. Yeah, and actually I have some news about another manipulator which was supposed to be presented by my colleague, but he will not join us, so I'll take it for him. It's a manipulator for testing of insulator, the ceramic insulator on the power lines, which is that brown thing on the left picture. And actually, it was tested, but on this kind of ultrasonic chain by our client. So the solution exists, and the client was quite happy with that, but it has broken. It was made of some plastic parts by 3D printing, so they want new manipulator and, let's say, some improvements. So what we done was this. It's actually the similar concept, manually driven chain with the ultrasonic probe, which is springed, and encoder, and some connecting buckle. It's a classical concept of the ultrasonic chains. It's all wired with cables. There is a water supply for the ultrasonic probe. And there was some challenge for placing encoder. We couldn't find any commercial encoder that would fit into the given dimension, so we made our own from just the magnet and the sensor. We connected it with some wheel, and it works perfect. And also quite a small thing, but very useful, was the grommet for the ultrasonic probe, where we used commercial probe, where is the connector on one side and the probe on the other, and you cannot use commercial rubber grommet on the cable because you cannot just cut the cable. So we used this kind of mold from upper and lower part. We placed it on the cable and we inject the silicone into it, so we made our own grommet directly on the cable. So it's that blue thing under that black cover. Okay, and actually this manipulator was commercial, so we sold it to client as a final product. So it was packed in the suitcase with all manual and with everything. The first manipulator was for grant project, so actually there were some things that are, for example, the control panel is a little bit sloppy, but this one has to be 100% finished and perfect, and so for this case, it was sold like a product, and it's using on the power plant. That actually reminds me that I've seen some questions for panel discussion, if we are able to supply manipulators for power plants. So yes, we are. This is one of them. We have about 5-6 references of manipulators that actually are using on the power plant for inspections. So we supplied, I think, 2 pieces of this one. Yeah, there's a video from testing on the sample of the insulator. You can see it's connected to ZTEC Topaz, standard commercial device for ultrasonic testing. So it was proven that it works, and that was it. Okay, thank you. As I said, you can see both manipulators on the tour. So if you want, we are looking forward to see you there. Thank you. Any questions?
We will have also opportunity during the panel discussion. So thank you for now. I forgot for the gift to the first speaker. This is also for you. And let me invite now our next speaker, who is Jaroslav Brom. And he will give you a presentation about possibilities of liner inspections. I will also shortly introduce him. Jaroslav graduated in mathematical engineering from the Faculty of Nuclear and Physical Engineering at Czech Technical University in Prague. Jaromír has about 33 years of experience in diagnostic and non-destructive testing at chast nuclear power plants and 8 years managing R&D projects in NBT field at the research centers. Jaroslav, the floor is yours. And you have enough time.
Okay. And will I receive 2 packages because I have 2 presentations? Okay. So, ladies and gentlemen, let me introduce research and development project. This is second presentation. So this presentation is about 2 running research and development projects. I will speak about possibilities for inspection of the liners of hermetic spaces and pools of Dukovany nuclear power plant. But these inspections can be used also in other plants. I will speak about so-called backscattering radiation testing project for the steel double liner of the spent fuel pools. And the second one, the project is for NDT voids between the liner and concrete with and without the presence of water. The project about backscattering started January this year and will end in December next year. Our main partner from Czech side is Bohuslav Kolar, who was here sometime before me. In this project, what is important that we are using special semiconductor photon counting cameras of Czech company Advacam. Here on the right side you can see their customers and contractors. CR is not mentioned there, but now we are in cooperation with them. They also have headquarters in Prague and one company in Finland where they produce semiconductor sensors and modules. On this slide are examples of their detectors. If you go to their web page, you will find description of mini peaks, EDVA peaks, and so on, white peak sensors. And for example, mini-pix sensors which we are using has 256 times 256 pixels with a pitch of 55 microns between them. On this slide is shown the capability of the detector. On the left side you can see the result from white pix sensor, then film imaging plate and Vidiscorazer X Pro. So you can see that their sensitivity is very high. And now let me speak about principle of backscattering RT. You have to have X-ray source which goes through slit with some angle, is dropping to a monitored object. In this case it was wood, and backscattered photons are going through collimator to detector. On the right side and in videos you can see that with this technique, for example, it's possible to detect wood with snack and tree rings. Another possibility of their detector is shown here. If you perform just a 2D image of the test specimen, you would receive something like this. But if you use their sensors and perform 3D scanning, then you can see now on the left side that I can have profiles of defects. We met in one workshop, and because we know or we think that we know what NPP needs, we prepared some test specimen and try to perform. In the first case, we received sorry. Here it is. We received this test specimen which was with some defects on the inner side, and from outer side there was composite repair. And when we used backscattering using these sensors, we could recognize all three defects with diameter 6, 3 and 1.5 diameter. Now I would like to show the second case. We had this test specimen. It looks like a repair of liners. In this case, there are 3 base layers: aluminum, polymer, and base material, metal-based material. We again fabricated artificial defects, crack type, and holes. And on the right side you can see that even we went through 2 layers, aluminum, polymer, we could detect defects on the inner side of metal part. After that, we agreed with chess that we try to perform and try to develop a method for double liners of the spent fuel pools of Dukovany NPP. On the right side, you can see that on the outer side there is austenitic plate, 5 millimeters thick, then there is a 4 millimeter gap, and then there is 10 or 8 millimeters ferritic plate. The defects which we should find are on the ferritic plate. So it looks like science fiction that going through austenitic plate try to detect defects. We agree that we will fabricate 2 specimens, first one with the hose and crack type defect, and the second one with so-called biological corrosion. So we have rings. You can see that on the right drawing of the specimen. On this slide, I wanted to show you that we perform many pilot measurements, and the first successful result was looking like this. In this case, SSOs, we had selenium 75. Then we had again many discussions how to improve experiment. We had to use tungsten to shield our detector from photons going from austenitic steel and from X-ray source. And the result you can see here. We can see that the method is working, but still there is some noise. Still there is, let's say, the time for measurement is between 10 and 30 minutes. So we have 1 year to improve this method. And after that, we suppose that we will have contract with chess to manufacture a manipulator. Draw pictures of spent fuel pool you can see on this slide. We will have to perform these measurements, let's say, between 5 meters from the surface of a reactor hull. So this is information about the first running research and development project. The second one is about developing NDT methods for detection not only voids between liner and concrete, but also to detect water in these voids. The project started January this year, and the end is March 2027. So it's me. When we perform pilot measurement, you can see if you use simple hammer, you can recognize by your ears presence of voids. We also perform impact measurement using vibration sensors, and it was the proof to persuade chess people to run this project. We are also trying not only develop impact hammer testing using vibration sensor. In the future, we would like to use also microphones, and we also trying to use another method like ultrasonic testing. And at the end of the project, we will also write a feasibility study of voice detection without water using a remotely controlled manipulator. For this project, we fabricated up to nine test specimen in Czech language, zkušební těleso ZT. So here are dimensions. You can see that just only one ZT7 has steel frame. On this slide you can see voids and concrete in the test specimen, and here you can see dimensions of voids. Here are photos for manufacturing of test specimen. We also have calculation support. So for test specimen ZT7, we perform simulations. And what is important that we simulated what will happen with the eigenfrequency of test specimen when we put between plate and concrete water. So if there is zero water column, the frequency is something around 450. 2-3 millimeter water column cause drop of the frequency, and 20 millimeters another drop, and if there is 300 millimeter water drop, then you can see that the eigenfrequency move from 450 to 300 hertz. On this slide, you can see our experimental results from ZT5 test specimen. First, we perform measurement without water, then with water. On the left side are spectrums from the place where there is connection between plate and concrete, and on the right side it's the place with a void. And what you can see on the right side spectrums, that the frequency moved from 350 to 300, and also amplitude dropped from more than 2 millimeters per second per Newton to less than 1 millimeter per second per Newton. So it works. Another method we would like to use is usage of ultrasonic testing. We are using pulse echo and also trying to use phased array. On this slide, I wanted to show you that if we put 100% energy from liner to water, then just 6.2 energy go to water, and back is going for 0.29% of original power of the signal. So if we would like to find echoes from concrete, we have to concentrate on small amplitudes, and is demonstrated here. So on the middle display, you can see that between echoes from the plate, backside of the plate, there are small echoes from concrete. But and from what concerns of phase array, we have some results, but still it's under development. On this slide, on the photos, you can see that we are speaking about many, let's say hundreds of meters square of liners which should be inspected. So from this point of view, it's clear that we should at the end develop some manipulator or robot which would go using magnets, and we think that we could use the manipulator which was presented by Mr. Netushil in previous presentation, manipulator from generators, using impact module, and that will be the end where we would like to enter this development and to provide to chess product which could be used for detection of the voids and even voids with or without water. Thank you for your attention. So now if you have some questions. No?
If not, Jaroslav, I think that you can continue with your second presentation.
Mám si ji pustit? Okay. The second presentation will be about our research and development project, which finished in June 2023. We called it Underwater Remote Replica Sampling and 3D Scanning in a Nuclear Power Plant. First, I will introduce the project, some requirements, limitations, then focus areas of the project, develop measuring systems. Also, one important part were verification tests, and then about implementation of the technologies developed in this project. Chess people from lifetime management were responsible or are responsible for lifetime management of reactor vessel, and there are 8 keys in a reactor vessel, pressure reactor vessel, and core barrel has on the opposite 8 grooves, and from the beginning or start of the operation of the plant there are some small clearance, but when all internal parts are out, then they perform video recording to get condition of these components, and then I recognize some wearing. And at the start of the project, they had information that if the clearance is more than 100 microns, then it can be problem for the lifetime. So we agreed, and this project was supported by Technology Agency of Czech Republic. But I have to say right now that during the project there were new calculations which proved that it shouldn't be no problem, but the project has already started, so the project was finished. The goal was to measure dimensions of grooves and keys with accuracy plus minus 40 microns, with high radiation up to 20 gray per hour, and underwater depth of keys is 8 meters, so to be on the safe side, we agreed that underwater to depth of 12 meters. The duration of the project was 36 months. Partners of the project was UGV, Řeš, Škoda, Machinery, and Czech company. What were our limitation and what were requirements from the plan that the inspections would take place at different times of the outage, because the measurement of the keys would be performed when inner parts are out and when the reactor vessel is full of boric acid, 16 grams per kilogram. What concerns of grooves, these measurements will be done on the air when they are moving to their position during the outage. Although the requirements was that to perform these inspections in the shortest possible time, because the inspections would be on the critical path of the outage. Here you can see so-called shielding cylinder. This shielding, in this shielding cylinder is a core barrel, and the core barrel has a window which should be which would be opened. You can see that on the right photos. And grooves would be in this window, and core barrel would be on the crane, rotating. So in this way we could measure dimensions of grooves. And although radiation would be too high. What concerns of measurement inside the reactor, Mr. Kolar showed MKS manipulator, originally developed by Škoda Machinery, which is used for inner inspections of reactor vessel or reactor vessel from inner side. This manipulator has a vertical part and a horizontal frame, and on this horizontal frame would be put our developed equipments for inspection of the keys. After many discussions, we agreed that we will develop two technologies, remote 3D camera system and so-called replicator for remote replica sampling. On the right side, you can see figures of mock-ups of a key and a groove. We also fabricated some defects, artificial defects. What concerns of 3D camera system, we made a decision that we will perform using GoPro cameras, video sampling videos, and using lasers, we can then perform 3D measurements. And what is also important, when you have this data, you have to have software to get a 3D point cloud. So that's what were focus areas for this project. And now what was developed? We developed two measuring systems, 3D cameras and replicators, and both of them had to be developed for keys and grooves, and they look a little bit different. In the middle is drawing of although manufactured 3D camera system. We were using 4 GoPro cameras, 3 lasers. What concerns of grooves, we would need just, because we would measure inner surfaces of grooves, we would just need 2 GoPro cameras. What concerns of replicators, in the middle is also manufactured replicator for grooves. And on the right side, you can see construction drawing of replicator for keys. These measuring these parts, a 3D camera system or replicator would be connected to, we will call it a manipulator. This manipulator, with this manipulator we could perform precise movements in a 3D directions axis. For measuring of grooves, we had to develop a heavy fixed frame, and you can see that this fixed frame also had one motor driver for moving manipulator to the measured component, and on these drawings you can see how would be manipulator connected to this fixing frame. Now to the verification tests. Because we were using remote replica in radiation conditions, we perform stability of this replica for radiation, and the dose was 40 kilograys with a dose rate of 2 kilogray per hour. And when we compared precise 3D scanning of these replicas, we didn't recognize any changes. So in this way, we proved that replicas are has radiation resistance. What concerns of 3D camera system, because we were using GoPro cameras with LCD sensors, so it's not known that they suffer when they are put to radiation area. We maybe accidentally put these cameras to the dose 180 gray per hour. and what we could see that yes, there is a noise, but because we were performing video recording, this noise was random. So if you perform video, if you have many shots, then still you can perform, let's say, scanning of the surface. So in this way, we perform verification that even if you use GoPro cameras, you can use it in a radiation area. On this slide, I would like to show you that using our infrastructure, which is used for local tests, we perform verification tests for pressure simulating water column of 12 meters, and also for verification that these systems works in boric acid 16 gram per kilogram. The big test was performed in Škoda Machinery Hall. They had a pit. There was a big pit. In this pit was a van, and in this van we installed for testing of 3D camera key mock-up. For a replicator we installed groove mock-up, and we had cables and everything for simulating 60 meters from the place of monitored component, and everything was working properly. The last test which I would like to mention is verification test of 3D camera system. We had some problems with the accuracy, because if you remember, we should go to 40 microns plus minus, but at the end we proved using our verification calibration piece, calibration block, that we could go to 52 plus minus microns on 80% of the surface, but on the whole, let's say 90 microns. Still, we think it's a very good accuracy of this 3D camera system. Here I would like to demonstrate verification test for remote replicas. Here we perform verification test. On the left photo you can see fixing frame, then a manipulator connected to fixing frame, then replicator connected to manipulator, then this wood window is simulating window of the shielding cylinder, and behind this wooden window is groove mock-up. Then I put here also design of the surface of jaws of replicator. These jaws were pressing to the measured component, and when we put there remotely replication mass, after some time we could get a replication of the monitored surface, and the idea is that when we When we have this replication mass in the condition where there is no radiation, then people can, using 3D arm, perform 3D scanning of this replica mass, and the result you can see on the right side. And you can see also that even when we performed remotely replica sampling, we could recognize artificial defects in the surface of the groove mockup. Here I have a video from 3D camera system verification test. You can see lasers. We were using key mockup, and it's demonstrated here that it was working. And now about application, implementation of developed technologies. What concerns of remote replica system, we are current days using simplified technology. We have just, let's say, a bell, and we put, let me, and in video you can see the black now is going remotely replica mass to the monitored surface. And we are using this measurement as an in-service inspection of the wet fuel storage tank of the CVR experimental reactor LVR-15. After scanning the replica, we can get the results. You can see the below curve picture, and we check if the defect is not growing. What concerns of 3D camera system, it was here mentioned or not, or no, it will be mentioned by Mr. Martin in the afternoon that for our customer chess, we developed system for VT inspection of the threaded holes of VVR 414, VVR 1000 steam generator collectors. Maybe it was mentioned by Mr. Kolář, no? We are using mirror, then GoPro camera, and from video we can get as a result, you can see gray photo. This is photo of threaded hose, and we can also get information about defects. And in this case, we are speaking about 100 microns size of defect. I think this is also, let's say, Meisterstück of our colleagues, of Mr. Marcin Kopec. Here, the technology of 3D camera system is now implementing for inspection of fuel rod surface, and up to now we could go to accuracy of 6 microns. On the first picture you can see picture when they perform calibration, then the right up picture is from the scanning, and the result of 3D surface you can see on the gray photo done. So that's all what I wanted to tell you about this project. Thank you.
Thank you very much, Jaroslav. Are there some questions now? If not, I have some. You mentioned many times using of some cameras and sensors, and there is really specific. There are specific conditions during the measurements and so on. Is there an issue with damage of the sensors, with some reliability of them?
If we speak about 3D cameras, if the radiation dose is too high, then Go camera costs how much? 11,000 Czech crowns, let's say 400 euros. So it's cheap to replace GoPro cameras. And what concerns of replicas, there is also, let's say, nothing expensive. So in this case, there is no problem.
Be easily replaceable, the cameras, but do you have this experience? Did you have to change it? Or?
No, because we put them to the radiation environment just during verification test. And it was those for 1080 gray per hour. So it was maybe 9 times higher than was prescribed in the project.
Some other questions? If not, let me thank you, and I have to thank to Jaroslav as he helped us a lot, as we had to change the moderator for the panel discussion, which will continue now. So it's hard to him to keep 2 presentations and then moderate the panel. Thank you, Jaroslav. But we can start with the panel. Let me invite the panelists. The first one is Ladislav Horacek from UJV. Then let me invite back Bohuslav Kolář and Jiří Netušil.
Okay, so can we start? So I think that I was introduced.
Okay, let me introduce myself maybe from the different perspective. As I said, I'm NDT expert here in the nuclear division of chess. My background is that I started in aerospace, I think it was 2012, and moved to outside agency level 3 services. So what I did, traveled through lots of companies in Europe and offer them my services as an NDT level 3 in variety of methods and systems. And 6 years ago, I ended up in chess in nuclear division, and from that time I'm there, and I'm site personnel, so I'm actually take care about everything on the site to go smoothly in the NDT field.
And I also tell that we met when I was in chess, and we were perform radiation testing underwater, and you were working for as a company for driver for SUGB.
Yeah, I was a few years. I actually worked under our Czech regulators, so I helped them with the NDT part of their work. So I have also a bit background in regulator part of the nuclear power plants.
Okay, so then Ladislav, can you introduce by yourself?
So, my name is Ladislav Horáček. So, thank you. I have worked first in the Škoda nuclear machinery. That was practically my career for about 15 plus years. And during that time, that was the area of, first of all, reactor pressure vessel materials and the other things connected with that. And after that, so that was a period when there were big changes in Europe, and Czech Republic was accepted to European Union, and for that time we have started also a lot of projects with European Union, and we have been supported by them from the point of budget for projects. So after that, in 1991, I
shortly, maybe.
So briefly spoken, yeah. So 1991, that was Kernforschungszentrum in Karlsruhe. That was IAEA Vienna part. After that, that was similarly the work at the Škoda after the Škoda nuclear machinery. I have started at UGV Žreš, and we made a lot of projects in the area of ISI. So that means, first of all, manufacturing of manipulators, support technical justifications and qualifications. After that, now we cooperate also, in this case, on the area of artificial intelligence applications for ISI. Thank you.
And about EG, CV, we heard already, so I think that we can start this discussion. I would like to put the first question. What are the latest trends in the development of manipulators for inspections in nuclear power plants? So maybe I can start with Jiří, because you are now receiving requests for construction. So if you could tell us what are demands from customer.
It doesn't be specifically in nuclear, but in general, the highest trends are in machine learning and image processing, digital image processing. So we are developing this system also, or we try to add it into our existing manipulators. So, but about specifically nuclear, it may be a question for the guys from power plant. So, what technology they want to like inspect or?
Okay, and what about you, Ladislav? I know that you are running current days project, research and development project, developing manipulator for inspections. So what new you incorporated to your manipulator?
So first of all, that it is important that big changes are in the in the whole hardware. So that means we will now concentrate our activities first of all for the whole system, and using that for different can you say different type of inspection areas where will be the appropriate different also parameters of inspection. So we are starting with phased array UT, and also we will have the appropriate can you say new activities, so involving also machine learning and AI to our projects to support and to make quicker the appropriate inspections. That is connected also with the fact that not only the inspections will be performed with new manipulators, and that will be devoted also to quicker, can you say, checking the previous inspections performed in the past using the IA and machine learning. So that is, can you say, something like summary of the activities which will be devoted to that. And a lot of new sensors are applied in that as part of IoT. Thank you.
And now, maybe to you, you mentioned that you have many manipulators. You also have, let's say, obsolete manipulators. Study old one. And if you want to repair them, you just want to have copy of the previous, or you are trying to incorporate your experience with them, replacing power with spout. So, what are?
Yeah, definitely. We are in the middle of the project of the renewal of our group of manipulators, which will be really important for us. And surely we don't need a copy of the old manipulators. So what are our goals, or what we will be pushing for is time of the inspection. That's on the first place. So
to shorten time.
Yeah, to shorten time of the inspection as much as possible. That's really important feature for us. So in place it's possible, so shorten time. Also, what's starting to be really important is repeatability. So the tests have to be repeated in the same way in the time. So the side of repeatability is also really important, and there will be quite a pressure for it. And also, of course, from point of view how much manipulators we are currently having, also the modular solution of the manipulators in the future will be better for us, because if you can have the main part of the manipulator and change, for example, just the head of the manipulator, and you can use it for different equipment in a power plant, is much beneficial for us to have.
Okay.
Yeah, and of course, as I heard here, the post data processing, it's also really, let's say, matter that has a rocket development right now. So post-processing of data, not just, yeah, sure. Let me finish, and I will be here in a few seconds. And yeah, not just the new data, but of course post-processing also the older data. And there was a question from the other end, I think.
Well, if you are speaking about the time, how long does it take now? And
I'm sorry, I will give you a mic for the colleagues which are online.
Just wait for mic and okay, great.
Okay, so when you are speaking about the time, how long does it take now, and how long do you want it to be future?
Okay, that's how long does it take? It's a really wide question because you have, of course, you have inspections which took hours, minutes, and you have an inspection which takes days and weeks. So there is no certain number we are focusing, not precise number we are focusing, but there should be time. Yeah, we wanna make it shorter, of course.
Okay.
It's also a question if the inspection is on the critical path of the outage. If not, that yes, time is important, but not so much. But for example, inspections of reactor pressure vessel, they are on a critical path. So
yeah, sure. You have parts which are in critical time, which is normally all parts around the reactor, spare fuel pools, or also steam generators, and actually everything on a primer circuit have to be really on time. Yeah, there are hours and I would say not days, hours, which are important in reality. So yeah, there was a bit pressure for time. Yeah.
No, I think
there will be. Sorry.
You want to save manpower also. Because the skilled human resources are limited.
Yeah,
it's difficult to find some skilled inspectors. So
you know, we are quite lucky that we stabilize our team during past these, I don't know, few years, 2 years. We quite stabilize our team on all the sources right now, so we have stable team.
Are doing stabilization in other companies?
Not that much. Okay, yeah, cannot be, doesn't have to be forever. Yeah, but of course in the future there will be quite less manpower. So, or in the industry in general, there is less and less manpower. So yeah, that will be also that is also quite good point in the discussion, that saving the manpower, or I would say it like this, not saving the manpower, but let the expert and technician focusing what is important, because to take the data, it's not really that important how to evaluate the data. So let's the technician and expert focus on what is important.
Yeah, but my point was that we developed some manipulator for testing of some piping, which was previously done manually, and there was a radiation, and the inspector could be there only for like 5 minutes, and then they have to change. So it took two men to do inspection, but with the manipulator they installed it, and only one inspector was necessary for operating, because the machine could stay there longer.
Yeah, sure. Time to time you have inspection where you have to prepare. Let's say 5-10 people in a row to, let's say, and personnel took part of this, and you know, you can be there 5 minutes, after second is another 5 minutes. It can be very helpful in these cases, of course.
Yeah.
So the question is, as you mentioned, repeatability.
Yeah.
In that case, once more, we have to highlight that it is importance of using, can we say, new technologies, this application of machine learning, deep neural networks and so on. So in such a case, we can substantially, can we say, replace the manpower due to the fact that using that machine learning results, the repeatability, when it is, can we say, the appropriate system is frozen and used several times, the results are the same. We cannot tell it what concerns persons. The experts can make some, can we say, some difficulties what concerns, for example, too long work at the power plant and so on, and that it is much more easier to use it with the technologies like machine learning.
You all mentioned that machine learning and artificial intelligence is the trend. We can also recognize it that also ENIC is European Network for Inspection Qualification, and they have already published documents for machine learning. They are preparing for artificial intelligence. So the question is, can we, let's say, for 100% believe that we can believe the results of AI or results from software which is machine learned? Yeah. Or what then will be the role of the man?
You are right. On the other hand, so that is importance of, can we say, like the recommended practice number 13, yeah, you mentioned practically. So in that case, that it is clear from that that you can use it, and you can use it several times, and substantial in that case will be also, can we say, part of qualification. And qualification, which is now performed for, can we say, standard inspection procedures with appropriate personnel, with blind and open trials, the same will be using, can we say, the other part devoted to AI and artificial intelligence. Yeah? So in that case, that it is much more, can we say, experience and needed, and we will have to do it, can we say, and cooperate worldwide. Yeah. In that case, the most important is now the appropriate cooperation within the European Union and the ENIC, as you mentioned, and on the other hand, that is also worldwide with the EPRI group. So with the appropriate, can you say, experience, we have also the appropriate, can you say, technical meetings with experts worldwide who work on this area.
And do you have interest, experience with such systems?
Well, I think you are a little bit stealing the question from the second panel discussion, which will be in, after lunch. But to answer your question, yeah, we actually started training artificial intelligence in 2024. We have one application for ultrasonic and expecting second application for ultrasonic this year or on the end of this year. The results are promising. So we are in process of using it. You mentioned the ENIC, the part 13, of course. As I remember, in Sweden there is a first qualification of artificial intelligence, and through the EPRI we have access from results from US and US plans, and the results actually, as I said, looks promising, but I think there is a long way ahead of us. So So in sense of artificial intelligence, I think after lunch there will be much more to discuss, but as I said, we are on the start and there is a journey ahead of us.
Maybe question to Jiří. You are a designer, constructor of manipulators. So do you use some special components, or because I think that in CVR we are trying to use, let's say, not cheap, but components which can be unbelievably used also in nuclear power plants.
Oh, we use standard materials like aluminum alloys, stainless steel, and 3D printed plastics. But
and we know requirements which material couldn't be used. We have this during the project for keys and grooves. We received these requirements from Škoda Pilsen, if you remember. So if we keep these requirements, then we can use what is in the market.
You mean like radiation, or which requirements?
Yes, from the point of radiation.
Yeah, but the material was fine about it, and we tested only the replica silicon, I think, and it passed. So, and then we tested some PCB or these cameras, some electronic devices, and there was no problem with that. So.
Yeah, actually, sorry to interrupt you guys, but it's a quite nice question. Actually, is there, because as far as I saw in nuclear for manufacturing of manipulators, we are using lots of steels or aluminum alloys. Is there any way how to use, for example, composite materials? Because I'm quite used to composite structures from aerospace, which there is really easy to use, much lighter than actually steel and aluminum. So is there any way how to more, let's say, put composite structures and parts to the manipulators?
I think definitely there is. But so far we are doing, let's say, small manipulators like those that can be operated manually, or you can bring them by hand to the site. So maybe that's for our, not competitor, but company that we cooperate with, Škoda ES. They do the big ones like NKS and ES and some which have load capacity in tons. So there could be used. So far we don't have any application, and I don't have any in my mind for which we can use these high-tech space materials or something. Not yet, but maybe we will in the future.
And maybe it's also a question to you from Czech company. In the world, the inspections are performed by suppliers, but it was maybe in the past it was also in chess, for chess. But nowadays, I think you have a big group of your own people, and your intention, I think, is that you will also own the manipulators. So the reason is, or can you explain it to audience?
Yeah, you are totally correct. We are holding lots of NDT personals for testing, as I showed you, expecting 100% of the inspection will be done by us internally. So we are. This is the goal. We are really close right now. So, and also we want to own the manipulators and everything. And the reason, and the most important reason, is quality, because if you move everything from the vendor to your company structure, of course it can be more expensive. Yeah, it can, but the quality rises every time. Every time, from my experience, when you move something from a vendor and you have direct influence to not just to the personnel but to the also technical things as manipulators and everything, the quality rises. That's the reason.
And maybe I have another question. Sorry again to you. You run current days two nuclear power plants, Temelín and Dukovany. So also, is it possible to run manipulators on both sides, or you have just specific for Temelín and the another one for Dukovany?
Well, of course, in case of the bigger ones, as I showed you, for example, the iris manipulator, the goal is now we can use it on both our NPPs, and of course, goal is to have manipulators not just for one or for both or any NPPs which will be in the future. But there is one really big challenge and big trouble, and that is that if you are using the manipulator inside of the primary circuit for reactor, pressure vessel, steam generator, primary side of steam generator, of course, and everything you touched can be contaminated. That's the thing. And to transport something which is contaminated from one place to another is quite special process, and it's not easy process to run. So much more easier for us to have one manipulator, the same manipulator on both localities. That's quite simpler than to transfer the manipulators from one to another. But we are doing this actually with the MKS manipulator. MKS is basically placed in Plzeň in Škoda. Normally they will actually pack it, and they will transport it to one or another our NPP, but there is a control area also in Plzeň, so you have to actually have, and you have to actually have also controlled area from point of the radiation in Plzeň. So one side more, and all of the radiation risk and everything you have to assess. It's not easy. Easier is to have manipulators on each each NPP. So we have this kind of manipulators, of course, the bigger ones, but
and also you can have less spare parts.
Yeah, sure. But as I said, from practical point of view, it's not that easy as seems to be from start.
Mm-hmm. And now I am thinking about another question. It maybe would be also for you. Dukovany is now running in, let's say, a long-term operation period. So do you think that if the lifetime or they are older and older, the components are older and older, do you think that you will need new one manipulators, for new inspections, or what do you think about some tanks? And because if we operate plant 30 years and then we stop to run the plant, then some inspections wouldn't be developed. But now, if you are in LTO, maybe you will have to think about, like for liners, as I showed, or for voids between liner and concrete. So what will be trend? What do you think?
Yeah, sure. We are expecting 60 plus years. So, of course, there will be challenges and there will be new tests and inspection which will be required. And of course, for this, we will need new manipulators. That's sure thing.
So I think then we are here. We can help you, both CVR and UGV. So maybe now I would like ask audience if you have some question or experience with manipulators in your countries. No? Okay, then I think I would...
We can mention, so during the day will be also the presentation which will be made by Mr. Dopiera. So that is one opportunity when you can see also high level, can we say, application of the newest manipulators which were developed during these projects. So that will be done, and you can see it in the special presentation. So what is important that during the long period we have practically be familiar with and compared with the situation also with France, with Germany, Spain, and also with the United States. And based on it, we have substantially improved can we say, the whole story about the manufacturing and the development of new manipulators. So that was really important.
Maybe I can see Miss Cappuccino Carpenter. You are coming from Rolls-Royce as we are. And you will run the project that first plan will be in UK, then maybe at Temerin site. And I think that you also will develop manipulators. So maybe the same manipulators at UK can be then used also in other applications. Am I right? Or do you think about possibility of usage manipulators from UK in other applications? Will you recommend it to new utilities to use already developed manipulators?
Hi everyone, good morning. Well, I think what's important is the application. So if I mean, what in Rolls-Royce SMR we are more focused on the manufacturing, so end of manufacturing inspection. So obviously we don't have the same constraint that you would have for in-service inspection, but at the end we have the same kind of focus, is having reliability of NDT. There is also the aspect of introducing automated inspection so that you also have an aspect of personal and quality of the data. So all that is also goal you will have in service inspection. And at the end is whether the manipulator is fit for a particular design and particular application. So the principle are there. It's just a question of adapting to what the design is. So yes, they certainly, I think, in terms of transfer of knowledge and technology, it's important to have that. You mentioned collaboration. You mentioned international community and working group, and it's important that we have that active collaboration and transfer of knowledge. I think that's quite key.
It's having consistency across the entire SMR fleet that we wouldn't necessarily apply on a national level, that if Rolls-Royce SMRs are deployed around the world, then there's no reason why you wouldn't use the same equipment across the entire fleet, country by country, so you get the same results. And that gives us an opportunity then to compare against fleet leader and then pass that knowledge around the rest of the fleet.
Okay, thank you. So I think we discussed everything.
I have a question also. It was partly answered and mentioned at the beginning of the discussion, but if you can explain, you mentioned many news in this field of manipulators using of AI and so on, but where does the need for the innovations occur usually? Is it the activity and offer of suppliers, or do you usually, let's say, on side of the operator require some improvements? How is or what is the behavior of the market at this field?
So I think that Slavek has already mentioned it, that they would like to shorten the time of inspection, the repeatability, and that's why they would like to have new manipulators. They also want to shorten time from the point of view of doses of NDT personnel. And in some cases, there are new inspections where the doses are too high, like close to spent fuel liners of spent fuel pool. And why to use AI? AI is used by physician doctors. And I read that AI can find defects in body more precisely than some doctors, because if they are machine learning, they can have many information, and some doctors maybe during their life do not meet with defect of body, but AI can, through machine learning, be learned to this. And that's the case also at the plant, because you have good welds, and some of welds will have never have a defect. So then they ask to manufacture test specimens with artificial defects, and mainly EDM is used, but EDM is very nice defect. It can be recognized by NDT techniques. So then they ask in some cases to have defects developed from cycling or thermal cycling, but still these defects are artificial, yes. So what I wanted to say, that if you have information from the world similar, then in this way artificial intelligence can help. So that's why also they ask to have artificial intelligence. But on the other hand, you will speak about it, artificial intelligence can generate more alarms.
As to answer to your question, the best projects all the time originates from problem or trouble on the site. So there is a need on the site, and doesn't matter for which company, and the site looks for solution. So that's, I think, the best source of the need of the manipulators is from the sites itself, yeah, from the problems on the site.
Okay, so let me thank to all the panelists. And now we can move to the coffee break and to make some fun.
What time we start?
Okay, good morning, ladies and gentlemen. My name is Jiří Duspen. I'm going to chair this second session, which is focused on NDTs. And let me introduce the first speaker, Mr. Pavel Mareš. He will present contribution on 3D scanning of components at the VVER nuclear power plants. Mr. Pavel Mareš is graduated in electrical engineering and computer science from the University of West Bohemia in Pilsen in 2006. Since then, he has been working at UJV Group, where he has been involved in NDT for roughly 19 years. And he's currently the head of department on diagnostics and qualifications in Research Center Rzesz. So, place is yours.
Okay, thank you very much. Good morning, everyone. Firstly, I have to say I have this presentation on behalf of my colleague Martin Krotz, because he is ill, so I'll do my best to tell you something about our 3D scanning at power plant components. So firstly, very briefly, I will show you some 3D scanning equipment which we are using. The biggest part of my presentation is an example of 3D scanning at inspection at nuclear power plants. At the end, some examples from the fossil power plants also I will show you, and some conclusions at the end. So 3D scanning belongs to our NDT laboratories, which are located in Pilsen. And we have experience about 10 years with this 3D scanning at the power plants. So firstly, how I said, the 3D scanning equipment. Here you can see devices we use and we own. At the left, here at the left, there is our older hexagon measuring arm with integrated scanning head and attachable touch probe for classic measurement. In the middle is his successor, the current model. It also has an option of attachable touch probe, but it's equipped with a much better scanner than the previous one, perhaps the best one right now. The AS1 it's called, with blue laser, with better accuracy and faster point acquisition, about 1.2 million points per second. And I can say this device is our working horse, because the most applications from the following slides were done by this device. And on the right is our newest addition, HandyScan. It's called HandyScan, which is handheld scanner. His weight is less than 1 kilogram, and it's very fast in point acquisition, because it doesn't have one laser line like the measuring arms, but 30 lines in form of lattice. It's very comfortable to use due to its compact dimensions and weight. But before measuring, the disadvantage is that before measuring, the object needs to be prepared by placing reference target on it. Both devices, HandyScan and the hexagon roller arm, will be presented at the technical tour later this day. Here is another device which we have experience to use, but we need to borrow them if necessary, except the laser profiler on the right. That device we also own. Leica AT on the left is a great tool for precision scanning on larger scale objects, because you hold the scanner in hand. It's this one. It's a scanner which you are holding in a hand. And device on tripod follows its position as long as it can see him up to 60 meters away. The device in the middle, Leica RTC, is for scanning entire rooms or halls in very short time. And it also captures HDR photos during scanning processes. And of course, the accuracy falls with growing range, but this device isn't meant for extreme precision. And on the right, the laser profiler, which is on contrary very precise, but in very small range. So we use it for evaluation of the most delicate defects, mostly for replicas we took somewhere else. So now go to examples for applications at nuclear power plants. First example is for scanning of main circulation pump balls. This is most common and perhaps easiest application. We scan the whole bolt and align it to a CAD data, and we can then create a core map which reveals all defects by means of different color, and then we evaluate each one individually. We mostly look corrosion and pitting, but also dents and scratches are common defects here. So on this picture you could see how the measurement performing on the top left picture here. And here is the evaluation of the some examples of the defects which could be found on this bolt. The second example is from main pressure boundary of the nuclear power plants. Measuring is done by our roller arm, and where we are scanning sealing grooves over the entire circumference on the bows of the pressure vessel. It's here, and also on the reactor head. The reason is an assessment of the state of groove geometry. Here you could see the cut of the one in one position. Here is the two grooves, and we are looking for changes in geometry in these grooves because we are performing the scanning during each outage. So we could look for the trends during each outage, where which kind of changes could be here in these grooves. The second example is scanning of sealing surfaces of NPP flanges on a reactor pressure vessel head. So the goal is assessment of the geometry of two sealing surfaces of the nozzle. Two sealing of these sealing surfaces. It's a nozzle of control drive mechanism on the upper head, reactor head, and we scanned all these nozzles. And there were two types of 3D measurement or assessment: measurement of imprints and deformations on each of these two sealing surfaces, and the second one was the measurement of mutual distances and flatness deviation of these sealing surfaces. The next example is scanning of the tubes on the secondary side inside of the steam generator. As you can see on the picture on the bottom, within the scanned data we look for corrosion pits and evaluate their dimension and relevance. If the measurement is repeated on the same tube, we also evaluated the change in individual defects. It's very important to monitor these tubes because the rupture could be very dangerous. So and on this picture you could see how this scanning is performed inside of a steam generator. So it's a very small area, and we are using our scanning arm. So it's very hard to be there and perform the scanning. And we are scanning almost about 90% of the outer surface of these tubes. Inside of these steam generators, there are in each steam generator there are 4 of these tubes. The next example is a scanning of guide groove of the wedge of the main closing valves of primary circuit. This measurement was quite challenging due to the confined space inside the shaft and the high radiation levels at the bottom of the shaft. We used a handheld device called HandyScan scanner, which we mounted on a custom designed pole with adjustable angles. This setup allowed us to lower the scanner all the way down the shaft and move it up and down during the scanning processes. We also designed and 3D printed a reference system for the scanner in the form of adjustable sticks with reference targets and put them next to the guiding pits. So system holds on a place by use of magnets on the top of surface of the shaft. Here you could see this reference system which we created for this type of measurement. The obtained data were analyzed for surface defects and overall geometry. The wedge was scanned separately outside of the shaft using a hexagon arm and evaluated in the same way as the shaft. Later, both scans, the wedge and the shaft, were combined. See here is the shaft and here is the wedge. And were combined in a simulated closed state to determine the clearance between them in several cross-sections as shown in this picture. Sometimes it's not possible to use a 3D scanner because of some limited space, like inside of threaded holes of some small bolts. So we have good experience with using replicas. So we perform replica, for example, from the inside of threaded holes, from the threads of the bolts. After that, for example, we scan this replica or put it to our laser profilometer, and then we could evaluate it in another equipment. Here is an example of a replica from a threaded hose of controller drive mechanism nozzles, and here is an evaluation from profilometer of defects which were found in the threads. Here is one of the examples of reverse engineering. So the goal is not to find defects, but goal is to create a CAD model for production of a new part, new component. So in this case, we scanned the old, it's called bridge. We performed reverse engineering. After this reverse engineering, there was created a model of wood plastic composite to verify if the production is clear. Then this wood plastic composite was scanned and compared to the original scan, and at the end was documentation for fabrication. Now here I would like to show you some examples from fossil power plants. Here is this example is our first application of 3D scanning at power plants. It was for steam turbine blades, and the goal was to find method for detection and sizing and location of corrosion pits. So it means in some steam turbine low pressure blades there are some corrosion pits, and these corrosion pits was initiation for cracks. So it could be quite dangerous. So it was necessary to evaluate their dimensions and locations. So the 3D scanning method was very useful for that. So after the scanning, based on a mathematical modeling, there is performing the evaluation of the criticality of individual blades in terms of remain service life with the risk of fatigue fracture. And this measurement and this evaluation of criticality is a prevention by exchange rotor blades on the end of service life. The second example is a scanning of steam pipelines. This application is focused to find spots of initial creep damage on these pipelines. After the scan is taken, we align it to CAD data we created for various types of pipes and their angles. And we look after changes in geometry, mostly ovality of these pipes. If the measurement is repeated, we use previous scan data instead of CAD model, so we can also tell the trend of the individual pipes. Here is some other example of reverse engineering which we perform on our research reactor LVR15. So on the left side, it looks like a mesh, but it's data scanned on the top of the reactor, and from this data and with some documentation, we created this reverse, we did this model of the entire state, of the current state of the equipment in our research reactor. This device was shown by my colleague Jaroslav in his presentation, so I only tell you that, how I said, we sometimes need to take replicas in areas which is not possible to use laser 3D scanning, so we create our own device to perform underwater replicas, and these replicas is after removing from the water. In this case, it was pool for fuel in our research reactor. There were some corrosion pits, so we take replicas underwater in this pool. This device was taken out of the water, and we scan it and evaluated the dimensions of these corrosion pits. So for conclusions, what is very important, the 3D scanning looks like some easy application. You will take scanner, 3D scanner, and then you will have 3D model. But for most of these examples, was some minor and major research, and is required before its deployment as a part of the in-service program of this power plant. Some of these applications even require their verification. In these cases, the European Network Inspection Qualification Methodology principles were applied for our power plants. And 3D scanning can be characterized as a new inspection method that provides a new type of results to evaluate the current state of components. Along with the ongoing development of scanners, which will continuously improve their accuracy, this method will be used increasingly often. So, thank you very much.
Thank you for your presentation, and we have a time for 1 or 2 questions, if there are any from the auditorium. I see.
Hi there. Thank you. Super nice talk. I have a question about the use of the 3D scanning in irradiated areas. So I'm imagining that what you're doing now, because you're, for example, when you showed the picture of LVR, that's all outside, so I'm taking that that's the low activation areas. Are you looking into ways to do it in sort of more of the highly activated areas to improve the scanning and also sort of the analysis of the area if it decays over time?
Thank you for your question. We are using these 3D scanners only in areas where it's possible to be also in person. So this radiation doses is not so high. So yeah, up to now we didn't see some influence of the radiation dose to our measurement. So, but in areas, it's electronics, so in areas with a high radiation dose, it could damage this device.
Okay, thank you for your answer. And because of time schedule, I would like to introduce the second speaker, Mr. Petr Živný. His contribution is on the monitoring of components during operation using the potential drop methods. Mr. Petrživny is graduated from the Faculty of Electrical Engineering at the University of West Bohemia in Plzeň in 2013. He worked for 23 years at the Brush SEM, where he focused on the production of large electrical generators and aftermarket services. From the past, for the past 4 years, he has been dedicated to developing advanced non-destructive testing technologies for use in the energy industry. So, place is yours.
Thank you very much for the introduction. Hello, everybody. I have a very long presentation in a very short time, and will be very briefly. I have the presentation about the monitoring of components during the operation by the electric potential drop method. That's a principle of the defect detection. It change current pathways during measure and voltage change enable not the destructive evolution of the materials. We sort of this method to the two main parts to the drop method ACPD or DCPD. ACPD is the alternative current potential drop method. This method uses the alternative current with a high frequency and using the skin effect was possible to check or measure the surface problems or surface cracks, usually our near surface, and direct current potential drop method is for the other materials, and for the direct current flow to the testing sample, and on the surface it's measured direct voltage according to the differences of the conductivity of this material. Application of AC or DCPD is depends to the what we need about the material properties and about the environment condition. Potential drop method application usually in the detection of the monitoring of the cracks ground, measurement of the wall thickness of the components, steel components, measurement of corrosion losses, and monitoring of the material changes. Application in the material laboratories is the standard. It's usually for the measuring of the defect and material properties, and a new application in the industry for monitoring of the critical part with the select components, and in the power industry. Usually it's used for the steam pipelines, components measuring, and sometimes it's possible to use for the construction, chemical, or other industries, and this environmental must be positive for this application. Current using of this method we use in the power plant, thermal power plants, several years. We use this measuring system in the pipelines with a high temperature up to the 550 degrees Celsius and pressure up to the 15 megapascals. Application in radioactive environments is possible, and long-term installation, usually that's very long time we monitor of this part. If it's some defect, not continue changes, and this application that's possible under the insulation, thermal insulation. Because we have the fewer experiences with this drop method in the industry, and we use for it commercial system for the measuring with not accuracy or not correctly data what we think it's better, and we prepared our new request for the developing of the new equipment. We have the two projects for it. The first name of the drop pod is develop of a mobile version or portable version functional devices. That's our customer is the chess. And this project starts in the 2024 and finish this year. And we produced a functional prototype of a mobile version of these devices. Second project is the online system for the measuring and for the remote monitoring system. And this name of this project is PotMet. This from the potential drop method, and this is internal project from our side, and this project start in the 2023 and finish next year. We developed the new online measuring devices with the created of the database software, with the evaluation of the data and comparison with the old data, and preparing the test samples for the testing of these devices, and calculation and modeling of the fields. The drop pod system is the typical configuration on the single measuring places. We use the 8 channels for the measuring. Old equipment has just only 4, and it's not accurate for the higher sensitivity. And few electrode configuration consists of the 2 excitation and 2 measuring system. Measuring quantities, it's voltage, current, and temperature. And example for the data post-processing for the elimination of the DC offset resistance of the channel and elimination of the dependence on the temperature. For the testing, we prepared the first basic testing samples, prisms samples. When we test the new version of the equipment, new products, and comparison with the other devices, and check the sensitivity and correct the data from the measuring. These samples used with 3 variants. First one with the real cracks, and last one with EDM defects, and next one is with the conventional machining defects. For the measuring, we applied lots of measuring and excitation electrodes for the testing bigger sensitivity of the systems. Here you can see the data from this experiment. That's samples for the testing in the temperature room and 550 degree Celsius. And on the graph you can see that red line because it's our colleague from the developed technology department support with calculation of the data for the comparison with real data what we measured. And it's, I think, it's very, very good similar data. And if we have the good experiences from this first test, we continue to the pipe test samples, but we change the thickness of the wall, change the position of the defect and angle of the defect, and prepare some special metrics of the connection electrodes on the surface, and combine the electrode system to the finding of the correct sensitivity for the measuring. After this test, we have this data. On the top side, you can see from the new equipment, and on the bottom side is 2 other equipments where it's not to identify the first step of the changes of the defect. Because the operator, if they see the data, you can, okay, sorry, it's not working. You can see that on the first steps is not correctly for the identification of some trouble in the testing samples. We prepared new data for the measuring, and after we developed the new parameters for the identification, correct identification with the higher sensitivity of the defect. You can see here that's in the first steps. You can see that's identification about the defect start in the material. That's all colleagues from the developed technology department. It's support with the numeric calculation and field modeling. On the right side, you can see that testing sample with equipotential lines. It's not. This demonstrates it's not easy for the measuring on the surface. It's very, very small values of the voltage, and this must be very accurate of this equipment. Our new equipment, lots of variants for the connection. This main part is the measuring units. This measuring unit pardon, is possible to connect to the evaluation unit directly, or it's possible to connect by routers, 2 or 3 outlets connectors. It is specification, basic specification about the measuring units. You can see that 4 channels for the measuring, and last green line is the green cable is for the measuring of the temperature. For the measuring system, the standard 6 units, measuring units, to the one evaluation unit, and for the power supply and other. In the evaluation unit, this power supply for the complete system by battery pack, and connection, it's possible to use the 2 or 3 inlets of the routers. The development system used the DCPD technique for offline cracks monitoring up to the 550 degrees Celsius. The sensitivity of the system has been verified by laboratory tests, and very important information is APRI evaluated this potential method as one of the methods for monitoring components of the new generation reactors. We have the framework of research of the development activities, electrode placement, welding of the optimization, and impact of the measurement system connection. And from my side, this basic message. This potential drop method has the big potential, because this system at the moment is with the high quality of the electronic components, its sensitivity is too high than maybe 10 years ago. Thank you for your attention.
Thank you for your contribution. We have a time for some questions, if there are in auditorium. there is no question, maybe I would ask if it would be applied in the nuclear industry for some, let's say, testing in the radioactive conditions. Is it strongly influenced, or what would be possibility how to, let's say,
this method is this method is possible to use in the radioactive parts. This is possible in the nuclear power plants, in the primer part. Maybe we will test on this one, but the basic part is just only measuring and excitation electrode, which is necessary to connect on the surface of the pipeline or critical component, what we would like to monitor. And the other part should be possible to connect by standard cable up to the outside from the radioactive part, and it's possible to measure completely.
You do not expect any influence by radiation?
No. Yes.
Okay, thank you. Maybe one more question.
Please, what will happen if a wire connection to the surface is broken?
We have the small experiences with it because usually we have a problem with the broken of the connection. But if it's possible to repair it, usually this data not exactly to change. And we would like to the specific software offset system that it's possible to repair this place for the measuring, and this equipment should be changed of the last data and continue with the measuring. Yeah, but it should be necessary to test.
Okay, thank you once more for your nice presentation and answers.